So limits at infinity have some shortcuts, and you have in your tutorial the long way to do things, and that's fine too. But understanding infinity kind of helps you get through these problems a little more quickly. So infinity is kind of like a concept, it's an idea of somewhere, it's almost a place where things just keep going. And you really shouldn't be treating it like a number. It's more of an idea of somewhere far where numbers keep going into the negative direction or into the positive direction. So I'm just going to give one example first. We're going to start with polynomials. And I have to go through this a little quickly because I have to go into live help. But we're going to go with limits at infinity with a constant. And those are pretty straightforward. The limit as x approaches positive or negative infinity of a constant number, let's say 5, is just going to be that number. Because no matter what you do as you get to infinity, let's say I have this line, no matter what you do as x goes this way, your answer is always 5 for f of x. 5, 5, no matter what it is. So that's why whatever the constant is, that's what you're going to get for your limit. Now, number 2 that I want to go through is if you have, let's say, the limit of 2x, because this is another kind of polynomial, as x approaches infinity. And if you think about infinity as this concept where numbers get bigger and bigger and bigger, if I was to times each one of those numbers by 2, they're just going to be double bigger. So you look at whatever's going on, you try and understand what's happening with your infinity at that point, and then see how anything around it affects it. So it's going to be even more infinity, which is just infinity. If you go through and do something like, let's say the limit of 2x as x approaches negative infinity. Well, what you're going to get there is it's going to be x is going more and more in the negative infinity direction. If I was to make that speed by double, if I was to times it by 2, I'm even getting there more quickly into the negative infinity direction. So that would be your answer. Let's go ahead and take this for 1 second so I have more room. Now let's say, let me get my next one. Can't get this to clear. Okay. Got it. All right, so now let's say that I take a different approach to what's happening to x. Let's see what happens if I take the limit. I think this might be number 4. I'm going to make it 4. That way you don't have to worry about that in your notes. Let's say I take the limit as x approaches infinity of x squared. Now I'm doing something different to x. Well, if I take 2,000 and square it, it's going to be some giant number. If I take 500,000 and square it, it's even a higher number. It's almost as if there's a direct relationship, which there is, in the positive infinity direction, which would make it more and more infinity. So you'd have infinity as your answer. And I say equals infinity here, but it really isn't equals. It's just notation. It's not really equals. But for notation purposes, this is what we use. Now, let's change it up a little bit. Let's say I take, well, I'm not changing it up really. I'm going to change it up in the next one. As x approaches negative infinity, the limit as x approaches negative infinity of x squared. Well, if I take 2 and square, negative 2 and square it, it's positive 4. If I take negative 10 and square it, it's positive 100. If I take negative any giant number and square it, it's still going to be positive. So your answer is still, it goes to infinity. And even though you're not plugging it in, it's kind of like plugging it in. Like you would a number, but you're not. But you would say, okay, like I'm kind of saying, well, infinity squared, but my answer is just infinity. It's not really a number. It's just more of a behavior that we're talking about. Now let's see what happens with a cube though. I'm gonna just do negative because we know what's gonna happen with the cubed. It's the negative that I really want to take a look at. If I take a negative 3 and I cube it, I'm going to end up with a negative answer. If I take a negative giant number and I cube it, I'm still going to end up with a negative number. So if I take negative infinity and I cube it, I'm going to end up with even that much more into the negative infinities. Now, if I have something like the limit as x approaches negative infinity of 5 plus 2x minus x to the third. Here goes one of the first tricks. Look at the degree of the polynomial. And I'm going to say highest degree just so that you understand really what I mean. So look for the highest degree. And really nothing else matters. Because no matter what's going on with the highest degree, these are just, we're talking about infinity here. So these little things, whatever they're doing can't affect what's going on big time with the infinity. And what's going on big time with the infinity is the one that's being cubed. So then I would just say, all right, well, I don't have to worry about these two, right? I don't have to really worry about that. Because it gobbles it up. Whatever happens here gobbles up what's happening here. It's infinity. So I'm going to go ahead and put in, I'm really just going to look at the limit as x approaches negative infinity of just this part, the leading, or the highest degree, which is just the degree, negative x to the third. Well, that means I have negative, and I'm not plugging it in, but I'm thinking like it is. I'm having negative infinity. Something's going on here. It's getting more and more into negative infinity. But then I'm going to cube that. So I've got this negative. So that negative means it goes even more negative infinity. And that means I'm just going to get negative infinity. So this whole part is right here. And negative to negative infinity is positive infinity. All right, so let's think about, I forgot what number we're on again. Darn it. All right, so I'll just make that 6. So let's say I have the limit as x approaches positive infinity of x squared plus 2x plus 5. And let's just look at the limit as x approaches negative infinity of the same one. So the first thing I want to do is eliminate anything insignificant. Well, these aren't significant. This is the big one. That's the biggest gobbler right there. So it wins on anything that happens here, you can't change what's happening because of this. So that's all that matters. Same here, same. So that would be, let's do this one. So that means that's going to be whatever the limit as x approaches infinity of x squared. So we already went through that. That's positive infinity. Now what happens here? This is the one that is a little tricky. Of x squared. That's all I'm doing, right? So that's kind of like I'm taking the limit as x approaches. This should have. This is horrible. Hold on. As x approaches negative infinity, and you want to say, oh, well, this one equaled positive infinity, so will this one. But no, because you're taking, and it's kind of like you're taking the concept and plugging it in here. That means all negative numbers, on and on and on, all numbers that are negative forever and ever. If I squared them, no matter what, I would get a positive infinity. So this is a big deal here. Make sure you notice that in this case, you get, oh, that's not that. Let's do this. This is the biggest deal, that you understand what's going on with those exponents. Squaring makes it positive. Squaring will make it positive. You got to read the rules. Oh, what's going on with my handwriting? Squaring makes, I'm going to sort it positive. All right, so let's get into another example. All right, if I have, let's say, the limit as x approaches infinity of negative x squared. So that means this part is squared first, and you're kind of plugging it in. So use what you know about even and odd powers. Use what you know already about even and odd powers. Everything you've learned in math comes to this point. So use what you know about even and odd powers. So in this case, it says you're going to take negative infinity. This was as x approaches negative infinity. You're going to take negative infinity and you're going to square it. Whatever you get here is going to be positive. So your answer in this case, because don't forget, you still have this negative. This is not the same negative. So now you still have this negative. So you have to bring it down, and that gives you negative. This right here ended up being positive because of the square. So you have negative infinity for an answer. And I'm going to stop there, and next week we'll go over limits of rational. Will be limits of rational numbers. Hopefully you see the patterns and see what you know with what coefficients change and what powers change and how your signs are, and that you understand that infinity is this concept of something far, far, far away where numbers go. It's not just one number that you're plugging in. If you have any questions, please reach out to your teacher, and as always, be great.